Hey guys, and welcome to Geared On For What. Today I have something really interesting for you. What the hell? If you want to know more about this robot here, you're going to have to follow me on Twitter. So now that I got the robot out of the way, today I have something really interesting for you. This is a compound planetary scissors ratio, or at least that's what I'm going to call it. So what does that mean? Well, let me show you. Crazy, man. So the input is here. These two rings are stationary and the output is here and here. The ratio between the input and the first output is 20:1, and the ratio between the input and the second output is 20 to -1, meaning that both outputs are spinning the exact same speed, but they spin in the opposite direction. So what could this be used for? Well, I've come up with a couple different applications, but I hope that you guys let me know what you think of. So the first one I came up with was a robotics gripper. That was kind of the idea behind this. And how you would do that is you would attach an arm to each one of these rings and then have it so that as you turn the input, the two rings close together. So if you use this for a robotics gripper, there's a really interesting application for it. If you drove it with a stepper motor, I have some really special stepper drivers, TMC 2130s, that you can set the drive current electronically and detect missteps. So you could effectively design a robotics gripper with this setup that would be capable of knowing when it's all the way open and then gripping on an object with a predetermined amount of pressure and actually knowing if the object was there, judging by whether or not the stepper motor starts to skip steps. So I think that would be a really cool application for this gearbox, this TMC 2130, and stepper motor. I think that would be a really effective means of doing it. If you're interested to know more about these TMC 2130s, I'll link Tom's video in the description for you. Another application I came up with for this is maybe some like a paper shredder type of thing that shreds with the wheels turning in opposite directions on one shaft. I thought that it could be interesting to see it work like that. You'd probably want to extend this out and have it would be A, B, C, B, C, B, C in the middle of it. So to give credit where credit is due, this is actually a project between me and Ross Korsky. So thank you, Ross. Being this is a gearbox that's 20:1 and -20:1, the ratio between these two middle ring gears is actually more like 10:1, which means that you can backdrive it. And you could see I've actually taken the planets out of alignment from doing this previously. But you can backdrive it, and it's really interesting because you could take, like I built this fan, and you could put this fan on here. And then I designed up this adapter for a drill that only grips on the ring gear that's closest to this edge. So this grips on ring gear number 3 and skips over number 4. And you slide that on there, and then you get your drill and hook up to this. And then you can do some really fun stuff. So yeah, I don't know exactly what the ratio of input to output is here when you're driving ring gear number 3 and holding ring gear number 2 stationary, because the math on that is just insanely complex, and I guess I don't care to figure it out. But it's around 10:1. So if this drill is rated about 1100 RPM, I imagine it probably only gets up to about 1000 with that much torque on it. And then I'm holding this, and then this should be spinning, in my mind, around 10,000 to 11 or 12,000 RPM. And it's extremely loud. Yeah, that's a stupid idea. So, if you want to know more about the robot, head on over to Twitter and follow me. If you want to download this gearbox on Thingiverse, I'll have a link in the description as soon as it's uploaded. If you have any questions or suggestions, leave a comment below. If you'd like to help my gear ratios reach a broader audience, hit that like button and share this video with your friends. And if you'd like to see more videos like this one, don't forget to subscribe to the channel. Hey, thanks for watching.